All right. Hello, everybody. Welcome to today's session. How are we doing? All right. A bit of a slow morning, right, after yesterday's pints. I also feel it. I can see the time is already ticking, so let's start. Today we'll be talking about 6 data engineering tips for Tableau developers. Now, how many of you are data engineers? Quite a few. Hello. Maybe you should come and join me here. We're going to be talking together. My name is Igor Galowski. I'm a founder of a small consultancy called DataDune, principal consultant there, also a Tableau ambassador twice already. Quite proud about it. Those are a couple of tools that we are working with. Obviously, Tableau in the middle of all of that. From more interesting tools for those of you that are not doing that, perhaps dbt, maybe DuckDB, a good equivalent of Snowflake, a bit cheaper if you were interested in that. So we're going to start from, let's raise your hand for those who struggle with dashboard performance at all, ever. Now, question to those who didn't raise their hands. How are you doing that? You never struggle with dashboard performance. Please come here and help me. What are we going to learn today? How are we going from this? And I know that the screens are not maybe the biggest. Probably you have a bigger TV at home. So I'm going to be reading a bit for you. This one says 160 seconds loading time, and probably you've seen it before. How are we doing it to 60 seconds or under 10 seconds? And mind that this is just the querying time. Now, for those of you who struggle with dashboarding itself, you should already know that if you have 100 sheets on your dashboard, probably that's the problem. But if you're looking at the performance, and you are querying for hundreds of seconds, then there are plenty of things that you can do to actually improve the situation. So what is the agenda for today? We'll be starting from talking about communication, because I believe that communication is the most important skill that you can have when it comes to data engineering, because majority of you will not be doing those things on your own. Majority of you work in a team. We are Tableau developers. You have to communicate this stuff to other people. And then we'll be going through several more technical parts, mostly data modeling, indexing, partitioning, and a couple of others. Now, let's start from the communication part. So having those two to read, how the data projects need clear goals and instructions. This is a clear, simple thing you can send to your colleague, or you can send exactly the same one that looks like gibberish. Yes, I used AI. AI, please generate something gibberish. That means exactly the same. Now, I know that those are two extremes, but the point here is that you, for sure, at some point of your career, receive an email where you're thinking, what the hell do they want from me? Now, we don't want to be those people. And to not be those people, we have to think about our audience. Now, this is Pioneer Plaque, 1972, sent into space. Why does it look so? Well, I cannot read it. You probably also would struggle. The thing is that somebody designed a message for other beings, having them in mind. When you're writing emails and messages, you should be doing it the same way. So, when you say, I need user data accessible in Tableau, you might get something behind a bastion in Postgres or DynamoDB, and you will struggle to use it in Tableau. Now, if I never work with Tableau, do you think I know what is possible and isn't? You are the experts. So tell the other people who are not the experts exactly what do you want. So instead of this, be more specific. I need GitHub user data only. I need it in Snowflake because I know this works well for my case. I want it aggregated by month, and I want it on a daily basis. Now, as a data engineer, I'm receiving a very simple message. Aggregate this stuff in the pipeline, do it on a daily basis, there's no on and off. Additionally, if you know what you're talking about, you can go for index it in that way. And why? The model design should be so and so, because it is serving my purpose. I am a Tableau developer. I have people who are using my dashboards. They have to be performant. It is my goal to satisfy those stakeholders. So you Tableau developers must understand some of the basics to communicate with the right people. Shortly, communication, clear, informative, actionable. Long story short, Remember all the emails that you are receiving and messages on Slack and Teams. Don't be that person. Be clear. And now having it out of the way, we'll be talking about the technical stuff, the cool part. So, in data modeling, I believe the most important is to speak about data normalization. Now, how many of you know what data normalization is? Quite a few hands. Not really too confident. I don't want to be taken out of the crowd. I get it. One of them is normalized, one of them is denormalized. The normalized table is probably what you call normal, because it has a lot of fields. It's the one on the right side. Now, in this, think about having everything mixed-matched. Think about having orders, having invoice numbers, then the name of the person who made the order, the quantity, etc., etc. Everything is together. That's denormalized. We want the left side. We want to have it normalized. We want to have this, what you might be thinking of, weird situation when we have hundreds of tables for no reason, and there are plenty of IDs, and I have to keep making joins. That's the correct way of doing it. And now, how is this going to be helping us? It's not really the speed, at least it's not directly the speed. Think about a situation when you are having a massive table, you're bringing everything in, and it's querying it really slow. Now, what you can do is you can normalize it and reduce the size. So instead of having this massive white table, now we are having several of them. The next step is that you will be doing joins to the minimum that we need. So if you're doing a dashboard and originally there was an invoice number, you don't actually need the invoice details because you're doing it for customer perspective, for example. Then you can do less tables. Now we have less data, which is better, obviously, and then you can materialize it. And how many of you know what is a materialized view? Quite a few. Nice. For those of you who do not know, you can think about it as a table. It's already pre-calculated. So when I'm sending a query from Tableau to the database, in a normal view, normal situation, the whole query of the view will be running in the background. It finishes, and then it's querying what we actually wanted. Materialized view is like a table. It's already pre-calculated, which is really good. Hello. For performance. Normal example, orders, customers, invoices. Everything is together. Again, performance is bad. We normalize everything. We split it into logical tables using a system we will describe in a second. Then we're making joins. As you can see, we removed a couple of tables, so we have less data. And then we created a materialized view. We basically cut off the data that we don't need. Because why to deal with too much data if you don't have to? So why not to do an extract, you can say? I'm doing extracts for everything. This is great. Well, yes, but what if you need, for example, data every 15 minutes, every 5 minutes? Don't you have any use cases where extracts are not good, where you will be every hour, all of you will be running on my Tableau server an extract? You're going to crash it. And frankly, it's also more expensive to run it. If you don't need an extract, don't use it. Database is made for computation. Computation there is cheaper. Briefly about normalized forms. You don't have to know all of them, but just so you know, there are many. So the way that we normalize things goes level after level. And the extreme situation is when you see a bunch of tables and everything looks like an ID. It looks kind of gibberish to you. This is the maximum level. The minimal level, it's more like a couple of big tables. Most often we are using the second normalized form of the third one. For you, what you have to understand is to go ask your data engineers and architects and say, which forms are we using? It should be one. And understand what it means, because there are different pros and cons of every form. So whatever they have chosen, and probably it won't be you to choose it, it will be helpful, because if you understand what are the cons, then if you would encounter it within the data set, you will not consider this as an error. Now, okay, I'll be reading this because probably you cannot see a thing. There are three different fields: employee, manager, and department. And this is also connected very much to the normalized forms. We have something called data anomalies. We have three different ones. We'll be speaking about the addition one, the insert anomaly. So if I went to add a department and there is still no person hired and there's no manager for it, then I'm adding nulls if this is denormalized, if it's just one big Excel table, let's call it. Then there is an update anomaly. If you are trying to update, for example, the department, will you update it on IT and BI from IT in this one table on all of the possibilities? But you can also go to another table and forget about it. What if you do an update here, but nobody does it in the pipeline, and we keep receiving IT, the old one? It's a problem that you might encounter. And then the third one will be the delete one. So what if Monica, who works in finance and she's the last employee, gets fired? Now, can you do dashboarding back in time if you're actually missing finance whatsoever? It doesn't exist anymore because the last entry was deleted. Normalization is actually helping with all of this. So in this table, and again, now we have 4 different fields: employee ID, employee manager ID, and department ID. Normalization often means to just create IDs and extract it to a different table. So we created a separate table called department. Now I have only 2 entries. It's only IT and finance. Well, and I'm always going too fast on this one. Go back, go back. If we were to right now delete Monica because she's getting fired, and let's say in your scenario we're actually deleting this employee, then it doesn't affect the other table with departments. You can still query it. It still exists. You know it was there at some point. If we went to change a manager or add a new employee, manager is still not there. You can work with the IDs instead of having a bunch of nulls. All of those anomalies that we've been discussing, they stop existing if you normalize properly. What it means to you, the developers, if you see those things in tables, it means that either this is done poorly and you should discuss it with manager and go and resolve it, or something is going wrong in the pipeline. Perhaps it is done correctly, but you see an error. And now you can say, all right, this is weird, I can resolve it in Tableau. Well, yeah, you can resolve it in Tableau. You can do scaffolding, you can do plenty of other things. Do you like doing scaffolding? Do you think this is a good idea to do it? And do tons of calculations to fix all the issues in the database? Whenever there's an issue in a database, we gotta go upstream, because this is where the calculations are being actually made. I can figure it out. Calculation was being made. All right, now it's fixed. Will my colleague figure out the same thing? Will everybody be figuring out the same things? Will I start making documentation about the existing tech debt that we have, so every single person who is onboarding has to understand we're doing it in a poor way? Or should we just fix it and do it once and properly? So, like I was saying, I can fix it in Tableau, but perhaps you shouldn't. The more things you resolve in Tableau, the more performance hit you have. Now you have more calculations, now you're doing LODs, now you're doing table calculations, removing stuff, etc., etc. So, next one, lineage and documentation. How many of you have perfect documentation and you know the lineage of everything that you're working with? 1, oh my God, I will find you after presentation. I have never seen it done like it's supposed to be, honestly. It's an endless push. It's always creating tech debt. And you know how it is when you're actually working with good documentation. When somebody communicates with you well, you know what are the requirements, here is the documentation, here's the JIRA documents, here is the business logic, here is the full lineage given to you by the architects. You just go and do it. It's almost a pleasure to do that. And you know the situations when it's not there. When you keep asking people, there is this weird guy who works for 15 years in the basement, he remembers all the lineage by heart and cannot get fired because the company will fall apart and nobody knows what's happening anymore. We gotta push for it because we are customers of the data engineering team. Oh, you are working with data engineering, so you have customers. Hopefully somebody is using your data. If you're not doing it with lineage and documentation, then what are you really doing? You're just providing a thing. It's like, why are you having a manual when you're buying any product? Because many people don't know how to use it. But you also gotta work on time and effort. So, are you working on one-time dashboard and an ad hoc, or are you doing a reusable data product? Again, question to you, how many of you know what is data mesh and data products? Couple of them. I really recommend you book about data mesh by, I'm gonna pretend I remember the author, I don't remember, Google it. It's a socio-technological framework which speaks mainly about what is data product and our customers. So taking aside the governance, the rest of the problems here, what it means to us is that we have customers of our data. If you, for example, consuming an API from some REST API, then you have documentation. Whenever REST API breaks, because there's a breaking change, then I, as a developer, I will be telling my customers, you, a month ahead, look, you cannot do this anymore. We'll be discontinuing it. Now, are you doing this in Tableau? If I am your customer and I'm having a financial dashboard and you are calculating profit for me in a specific way, and somebody somewhere told you that we have to change it, did you tell me ahead of time of that? Or will I one day open your dashboard and think, the numbers are weird, I made screenshots last week, this doesn't add up anymore. It's because you didn't inform me about the breaking change. And this goes also for data engineers. If they are changing something in the pipeline, if a field is being renamed, are you being informed ahead of time? Well, I would like to be informed ahead of time because I have to make changes, otherwise my dashboard will be broken. Now, data mesh speaks about this and more, so I highly encourage you to do that. And that's why I'm talking here about reusable data products. If you're doing it the right way, then going to data engineers and pushing for all of those changes makes a lot of sense. If you're working on an ad hoc thing, then perhaps actually doing those calculations quickly and dirty is a good thing, as long as you realize it's a tech debt. You will have to pay it sooner or later if this actually becomes a production dashboard. And additionally, why are we speaking about this? Because, for example, when you're editing a relationship, so you have the cardinality and you have the referential integrity. If you know about data, if you understand what's happening in the background, then you can set it up correctly and improve the performance. If you set up this incorrectly, you will actually lose some data. And I've seen it before. And then you will call somebody, can you audit it? Can you help me with this? This is one of the last places I will be checking. How many of you will be checking edit relationship for missing data? You'll be checking all the other things, the database, the calculations. You gotta know stuff to do this stuff correctly in order to improve your performance. So consider the following. Do I use all the columns? And now we're speaking again about the normalization. If you don't, hide them. Hiding also, when you're doing extracts, it creates some computation. It should be done in DB, especially if you're doing it live. Can I make less joins and unions? Now, if you're doing the normalization, then you're joining everything back, then frankly, you're just wasting performance again. Maybe materialized view. Again, going to a data engineer, explaining it to them. Do we experience anomalies? Perhaps something is wrong in the pipeline, but also in the setup itself. And structure, schema, is it understandable? Do you have documentation and lineage? Now that was the biggest part. We're continuing with a bit easier things, I hope. Indexing. Click. Fantastic. Select everything from employees where employee is Toby. Now this is a simple Tableau filter. This is the query that is being sent to the database. And this is the table. It is being ordered by the employee name. Now if you actually were saying it, I would ask you, where is Toby and how easy it is to find it? Because it is alphabetical, it will be quite easy to scan through the table. You know it's A, B, all right, I'm gonna be jumping somewhere to the bottom, we're looking for T. If I were to order it by the employee ID, then frankly it becomes a bit more difficult to look for Toby. But it becomes easier to look for number 6, because it's ordered by it. Now database doesn't work exactly in that way. It's a simplification of something called a full table scan, but you get the idea. ordering really matters. And the second thing that matters is the data type. Is it easier for you to scan through an URL, which has 255 characters, or is it easier to scan through an ID? That's the reason they're always pushing to use those annoying IDs. All of this in a database works in something called a data block. Now, data block starts from 0, 1 to 3. You have different blocks, and in every block, you have index 0 and 1. Inside each of those, in a grid, you have an array. Simplification a bit, let's think that in every single cell there is an entire row. It's only true if the row is not too long. When we're doing indexing, again, a bit of simplification, there is an indexing table, a hidden one in the background. If I say index on employee name, what's happening in the background is that we are having additional table of employee ordered alphabetically, and then we're having mapping with blocks and indexes. So if I'm looking for Toby, what the DB will do, it will go through the list until Toby, the mapping says block 2, index 1, and it's happening in the data blocks that the entire row is being retrieved. So instead of scanning the entire thing, it is scanning only this thing based on the order. And why is this really helpful? It wouldn't be that helpful if we're just working with linear way of adding data. But we have something called B-tree. Now, again, at the bottom, we have numbers. It starts with 4. And what's important in a B-tree is that to the left side, we always have smaller values, and to the right side, we have bigger values. You know, for example, that every character in a string has actually a number. So we can define which one is bigger or smaller. If I'm looking for number 1, in a normal way, I will be going in a linear manner. Let's say I'm looking for number 100. So I'm going from 1 until 100, and it's finally that you have to scan the entire thing. That's what machine would do. Thanks to something called B-trees, the binary search tree, I'm saying, if I'm looking for number 1 and I'm starting with 4, is it 1 bigger or smaller? Okay, it's smaller. I'm going to the left. Now I cut off 50% of the data because I know that the whole inner side is bigger. Now we are number 2. Is 1 bigger or smaller? It's smaller. Another 50%. We are already at 25% of data. Why is it important? Because we're going from the linear one to the linear one. And look how it's curving. It's because the more data you have, the less time of computation you're adding. Because each time you're cutting off 50% of the data, and 50. At 3 levels, you're already at 12.5% of the entire data set that you're looking at. All of this is really important, indexing, if you have massive amounts of data. So, use most common filters as indexes. This is coming for you. It's very important because if I'm a data engineer, I have no idea what you're doing on your dashboard. You can be doing filters by URL. It's not like I'm going to check all the queries that your dashboard is sending to me and I'm going to start indexing it. You have to figure out what's the right index, preferably an ID, a short name. This is why we're not using URLs. We're trying not to. Then use short filters for the indexes and use high cardinality. It means uniqueness. You shouldn't be using low cardinality when you have in a whole database just 3 different values. Preferably every row has a unique value. Hence, we're using IDs. And this will improve performance exponentially for you, actually logarithmically. So why are we talking about all of this? Wouldn't you prefer right now to go for a coffee or a beer instead of sitting and listening about data engineering in the morning? Definitely. But does your team know about your dashboards? This is what I just mentioned a second ago. Do the data engineers know exactly what you're doing? If they don't, then we're going back to topic number 1. How do you communicate those things? Do you send an email, give me some data? Or do you send an email, give me a data, this is what I'm trying to achieve. I think, based on my knowledge, that the index of this table should be so-and-so with those fields. Suddenly, you're totally different ballgame. So, you would say, index it all. That solves all our problems. But remember that in many systems, now every database is a bit different. In Snowflake, it will work significantly differently than in, for example, MySQL or Postgres. But you gotta strike a balance, because you have in some databases things like reindexing. So think about ordering 1 to 10. All right, but what if we're doing it by name and suddenly we're adding a name which goes in the middle? Well, you have to reindex it. Something has to go and reindex the whole indexing table. This is, again, computation. If you're working on a big data set, for example, almost a transactional level, then this will be a massive problem for the database itself. This is why we're not doing indexing on everything all the time. And always discuss it with the data engineers. As long as you know more or less what you're talking about, what you really need, discuss it with the expert. It's the same what your stakeholders are doing, right? You have stakeholders who are coming and I would like those and those insights. Are you just throwing your hands in the air like, all right, I'll be doing anything you want, mate? No, you're having a discussion. They know more or less what they want. They're not experts. You're the experts. So you're advising them, as long as we're having some kind of common ground. Next one, partitioning. Let's say that we have a table of products with sales, and we're having in product only consulting and subscription. What if you're trying to make a dashboard only about consulting? Do you just go, filter out in Tableau, majority of the data that you don't need? No, you can do it on the database level. Because again, why to stress your dashboard and the server? Instead of what you can do is work on an actual data that you need. So before, we've been cutting it from many columns to few, and now we're trying to make as little rows as possible. You are having two different tables, one with consulting, one with subscription. Simple. Go to data engineers and tell them, look, I want a presentation layer. Recalculate it for me. I don't want to do it in Tableau. Another idea you can have, tiering. This is based on the amount of time the data exists. You have the hot, warm, cold, archive, and purge. Usually we're doing it, the hot one is 31 days, then you have the 12 months, 5 years, previous 5 years, and then you're just purging the rest. So if you're working on a data of sales, perhaps you need only last couple of months. You'll be using those two tables. Very often we're working with data that's only 30 days. All the data, it just keeps moving to another tiering. And eventually you're purging it. You really don't need sales 15 years ago. You're probably going to Tableau and saying filter last couple of months. All right, but if you're querying database, that this is being sent in a query, select everything from the database where it's last 5 months. All of this creates a lag. You should always work on data that you actually need. So, what to communicate with devs? Select the right indexing field. Part of this work is you. If you are nevertheless selecting a wrong field like URL, it will be slower. And then use smaller subsets. Try to cut the data to the minimum, not in Tableau. It's fine to do it in Tableau at the beginning. Then you have probably poor performance. And then you go into data engineering and say, all right, cut it a bit. I don't want all of this. We're not using it at all. It's fine to have more tables. You're scared of having more tables because you don't have lineage in documentation, which is the other problem. If you had it, then it would be very easy to understand. Optimize aggregation. Very simple. Again, we're just squeezing the data. Don't do it in Tableau. There's no reason for it. If you really need it on a monthly basis, why are you bringing 15 million rows to Tableau? Bring only 7. Do it on the level of the database. And always remember that Tableau is good in many things, but it is not an ETL tool. So how many of you are being asked to create a table just so people can download it later? This is creating an ETL system out of this. You are using a visualization tool for your users so they can do something that's supposed to be in a database. And I know sometimes it's not possible to push back because they would like to have those fancy filters and only then download. All right, but at the same time, you are slowing down the server for the users who actually try to use the Tableau desktop, Tableau server for the thing that it's supposed to be used for. So, Raise a hand, how many people know what is data profiling? And how many of you are doing it? Data profiling, 1, 2, 3, 4. All right, well, that's not majority of the room. Data profiling is when you're starting your work and you go into a, for example, system. On the left, you have a screenshot from DuckDB. On the right, you have Tableau prep. All those ways to quickly discover what is the data about, how many nulls are you having inside, how many unique values do you have. This is going to help you when you're creating your dashboard, for example, to understand filters. This is going to help you to talk to data engineers before you start working, saying, why are we having 11% of nulls on a field that is imported at to our database? That should have no nulls whatsoever. Why to start creating a dashboard if down the road you will discover that something is really off and the whole data set is wrong? And nobody knows about this. That's what data profiling is. In DuckDB, you can open this one with, seriously, 3 commands, including installing DuckDB in under a couple of seconds. Tableau prep, you know how to do it. You open a database, you scroll through it. That's profiling. So for example, I'll be going inside of the database, and I'm noticing that we have address 1 of email and 2. I can create a TRS email, make a coalesce out of this. When should I do it? Should I do it on the dashboard? Well, again, you're moving more and more calculations to the dashboard, which sometimes is fine, but majority of time, if you're gonna overdo it, then you will have a bad performance. Another issue you might have noticed, all of them are null. Well, eliminate them. Again, normally you would just drop a filter and say no nulls. Well, that's great, but why are we having this in the database in the first place, if it says only nulls? Maybe we don't need it at all. Maybe you're having thousands of rows like this that are slowing us down. And the third one could be some duplicates. Again, you can remove duplicates in Tableau. You probably should do it on a database level. Aggregate in DB, simplify and transform in the DB itself. You are the final step of this. Before me, the stakeholder, the business stakeholder, you have to decide what is the right balance. Majority of the time, push it back to data engineers. I know they are busy, but some of those things are really not that complicated. If you speak Tableau language, then you also know SQL. If you know SQL, you can do things like materialized views within a simple pipeline. And if you cannot, then you should have documentation to be able to do it. So step by step, you can take over some of those parts because data engineers are just busy, and it's fine to do some of their work. It's definitely not fine to push everything to Tableau and say, look, the server is slow, I don't know why. Well, we are part of the problem. We are the developers. Platform, OTP, and OLAP. Now, you have 2 different databases, and you should be using the right one. Some architects and data engineers will tell you, oh, you can use either of them. We are so good at scripting that it's doing everything magically. And my comment to this is, if they actually did it, you should start selling this as a product because it will be the best database out there. You should know which one you're using. The transaction one is for a lot of transactions coming. For example, if you work for Tesco, you'll be having hundreds and hundreds of thousands of transactions every single second. That's not where you want to connect Tableau. It doesn't make any sense. You can do everything that I spoke about before. If you're connecting to something like this, it will be slow nevertheless. You gotta use the right tool. Use OLAP, Redshift, BigQuery, Snowflake, DuckDB. Those are the databases you want to use. And they are asking you to connect to Postgres. And like, I don't know, just make an extract. Yeah, here we go again. Extra. Documentation, it's for all of us, honestly. Lineage, it's gotta be out there. Entity relationship diagrams. This is something that we showed at the beginning when I was showing you that I'm taking out a couple of tables from the joins. And documentation. You gotta have it. This is not a negotiable. Monitor the performance. this is something for you again. Even if you do all of this, at some point it might start breaking. For example, you didn't anticipate a year ago that there will be an inflow of data that's significantly higher than it was before. Now you went from a couple of million rows to a billion of rows. Now, do you know, how many of you know that all of your dashboards that you ever created are still being used, are performant right now? One person. We don't know that because we are not the users, right? We are the developers. You're not going every week and clicking through all of the filters and like, oh yeah, I did such a good job. This is still great. You have no idea about this. Your users do know. But let me ask you back. If something is malfunctioning a bit, not enough to go to the bureaucratical system and try to find the owner of all of this and try to push them the feedback, please fix it. Do you just kind of use it? Maybe you stop using it. Maybe I will just download an Excel and do it on my own. This is loading for 20 seconds again. I complained to my manager. We didn't complain to anybody else. I just kept it to ourselves. So it is our job as Tableau developers to figure out how to monitor the performance. The easiest way? Make yourself a monthly or quarterly reminder. Spend an hour. Click through a couple of those things. You don't have to measure the performance. Just make sure that when you click it, it's workable. Or go to your users. You can make a quarterly quick questionnaire. Probably a part of your developer experience, whatever you're using, DX or any other questionnaire. Are the dashboards performant? No. No. All right. Who is saying so? Sales department. Sales dashboards are not working well. Let me go and check it and fix it. It's not working. Why? Okay, the dashboards are connected directly to database. You take a step back and you fix it. We fix it. I fix this stuff because I am the owner. Part of what I was saying about data mesh is ownership. You create it. Let me put it that way. You name it, it's yours. Takeaway. Proactive communication, normalization is your friend. Indexing is filters. Then you have also the partitioning of the data. Aggregation. So we're squeezing it. Then we are making less rows. We document all of this. We put it in the right database. And then we document the whole thing. It's as simple as that. And as difficult as that. Because in the end, you have to communicate all those things. Now, if you want to learn more about this, you can reach out to me. I'll actually put a QR code so you don't have to try to read it. Always happy to help. Always happy to jump on a call, discuss your use case. Anything you need, seriously, I'm here. Thank you so much.